Okay, this unit is going to be about solving equations. We'll start with solving quadratic equations by factoring. Now, the key to this one is being able to factor, which of course we spent a couple of weeks at the beginning of the semester reviewing factoring. There were specific steps that I had to follow. One of them was that the very first step you should do is GCF. Always look for a GCF first because it can simplify your problem completely, especially when you're doing equations. It'll simplify it a lot. Then you count the number of terms. If there are two terms, you look for this guy, difference of squares. Two perfect squares. If there are two terms, minus in between, it'll factor into two binomials. We call them the twins, but they're not identical. If it's a sum of squares, if it's not a minus in between, then it's not going to factor using that difference of squares. These guys right here, sum and difference of cubes, we haven't talked about those yet. I'll talk about them when we get into bigger equations that we're going to be solving. If there are three terms, these are the easy ones where the a equals 1, and you just double bubble them. Or we did the x, right? Two numbers that multiply to c but add to b, and then those are your two numbers that go in your bubbles. The harder ones, and this was when a was not equal to 1, I showed you how to use the cloud. You're welcome to use any method that you want. It's completely up to you. Quadratic in form we haven't talked about yet. We'll get to that when we get to higher powers. 4 more terms, that's when you use grouping. Remember, you group, factor out a GCF of each of them. What a coincidence, right? That's my favorite ones. What a coincidence. Love coincidences. And then write it as coincidence and leftovers. Also, don't forget to look at your final answers to see if they factor further. If you remember, we had some that factored into like this. And then if you look at this one, that's actually a difference of squares again. So it can factor further. I think that actually might come in a few lessons later, but be aware of it for right now. Okay, so solving by factoring. The key to this is called the zero product property. Right here, the zero product property says if you multiply two things together, I'm going to call them A and B, if their product equals 0. Well, the only way you can multiply two things together and get a 0 is if one of them's a 0, or both. I mean, you could take 0 times 0 and get 0. That's a lot of zeros being said there. My favorite first example is if I tell you 3x equals 0, what can you tell me about x? Well, automatically you can say x has to be equal to 0. That's the only way that if you multiply 3 by that number, you get a 0 out of it. So then we usually move on to bigger, but I think you get the idea. So we're going to use that. The first step is you've got to make sure your equation is equal to 0. If it doesn't equal 0, this product property doesn't work. It has to be equal to 0. So that means move everything to one side. So move everything to one side. You choose left or right. I tend to always go left, but sometimes that results in like a negative a value in front, and those aren't fun to deal with. So you can move it to either side. Just be strategic about it. Okay, you've got to factor completely. And again, that's where this little reference sheet came from. It's to remind you to factor completely. The idea is to get a bunch of things multiplied together equaling 0, right? We made it equal 0. Now, if we can factor this, these are the factors, then we can apply the zero product property, which just means make an equation for each factor, equal it to 0. Hopefully by now this is ringing bells. And then, of course, after that, you're going to solve each equation for the variable. So I'll walk you through when you're going to click and go, oh, this is easy. I remember this. Let's see, x squared minus 4x plus 3 equals 0. Okay, equal to 0. Check. Now we look at the left side and we factor. Now I know the tricks, and I know that there's no GCF there. The main one being that not everybody has an x, and this guy out in front is a 1, which tells me it's going to go into a double bubble. X and x. I need two numbers that multiply to 3 but add to negative 4. There's only so many numbers that multiply to 3, right? To add to negative 4, though, they need to both be negative. So we've got x minus 1, x minus 3 equals 0. Now the zero product property says if I've got some things multiplied together, it doesn't matter that the thing's this set of parentheses with stuff inside, then either this thing was equal to 0, turning this whole thing into 0, or this thing equaled 0, which means no matter what, I would multiply by something times 0 and get a 0 out of it. And then you finish solving. So in this case, x equals 1 and x equals 3. And those are solutions. Okay, this next one, I'm looking at it and going, okay, wait, it doesn't have a 0 on one side, so I'm going to subtract this 4x over. That will make my 0. Negative 2x squared minus 4x minus 2 equals 0. Now this looks weird because that number out front is a negative and it's not a 1. So my first trick is to go through and see if I can divide by that coefficient. If I can just get rid of the negative 2, then it goes back to the double bubble type where I do an x and I find the two numbers, right? So I'm going to try it. Can I divide everything by negative 2 and have it come out nice and clean? Don't forget to divide the other side, even though it's 0, he still gets his chance, right? So I end up with x squared plus 2x plus 1 equals 0. Perfect. It worked. Everything got canceled. If it hadn't worked, I would have still divided by negative 1 to get rid of the negative, but then I would have went, oh, a has got to be 2, so I'm going to use the cloud method. Okay, this one, we're going to crisscross, see if we can figure out what numbers multiply to 1 but add to 2. Not a lot of numbers that multiply to 1. 1 and 1, add to positive 2, it'll be positive 1 and positive 1. Still equal to 0, but since it is equal to 0 and things are being multiplied, that means this can equal 0. Oops. Or this could equal 0. Do I really need to write the same thing twice? No. So that one only has one solution to it. Factoring by grouping, or sorry, factoring by solving by factoring. Okay, this one. First step, again, get everything to one side. I'm going to move the 3x over. So I've got 6x squared minus 3x equals 0. And then I go to factor, and I'm looking at it, and I'm going, okay, it's not the x one, because it's not a trinomial. It doesn't have 3 terms, right? So I can't do the whole 2 numbers that multiply to this, but add to that. I go, okay, it's 2 terms with a minus in between. Do I have square roots? No, I don't have that. So I get stuck. Okay, I go back to my reference sheet back here, and I go, okay, what did I do wrong? What am I missing? Blah, blah, blah. What did I forget to do? Gosh. Very beginning, always look for that GCF. Now, I know some of you can see it in your heads just by looking at it, what the GCF is, and that's fine. You don't have to write this process out. Some of us need to see it. So factors of 6x squared, 2 times 3 times x, factors of 3x. So it looks like they've got a 3 and an x in common. Oh, sorry, hit the mic. So I'm going to pull out a 3x, and my leftovers are 2x minus, and there's nothing left over. Should I just close my parentheses? Should I be done with it? No, the superhero comes in and says, da, 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 I'm here. I can hold a place there. Okay, thanks, superhero 1. All right, so now what we have is some things being multiplied together, and their product equals 1. I've got this 3x being multiplied by 2x minus 1. So each one gets its chance to be 0. It could be this guy. It could be this guy. Everybody gets a shot. Finish solving. 3 times x, I divide by 3. 0 divided by anything is still just 0. Add the 1. Divide by 2. And we get our second answer is x equals 1/2. If you ever want the warm fuzzies to make sure that you got it right, remember you can always plug your answers back in for the x's and solve and make sure it's true. Okay, this one. I've got to set it equal to 0 again, so I got to get rid of the 1. It gives me 9x squared minus 6x plus 1 equals 0. Okay, I got a 9 out front. I can't divide by that and get rid of it, so I'm just going to have to deal with it. For the cloud method, we would take this 9 and that 1 and multiply them together. They're joining forces, right? But what it really does is it gets rid of that 9 out in front so that we can do a very easy factoring, a double bubble to numbers that multiply to 9 but add to 6, adds to negative 6, so they're negative and negative. But we use the cloud method, which means we have to take that 9 and divide it back out. Okay, so this reduced is 1/3. I've got x minus 1/3, same thing. We don't leave the fractions though, so we're going to take the denominators and they go back out front. And so our factors are 3x minus 1 and 3x minus 1. Now remember, that was initially equal to 0, right? We just had to set that aside for a minute while we factored. Okay, they match, so I only actually need to write one of them. But if you're multiplying together and you equal 0, that means one of you equals 0. Okay, finish solving for x. It's not always that x equals 0, it's what value, if I replaced x with it, would make that stuff in parentheses turn to 0. And in this case, it looks like x equals 1/3.